Now say that we don't want to end up at this competitive equilibrium point. Perhaps the government has decided that this is not a fair or desirable allocation for some reason, and the government would like us to end up at some other point along the contract curve. The second fundamental theorem of welfare economics tells me that any competitive equilibrium can be achieved and sustained simply through a set of transfers from the initial endowment point. That means that if I take some value away from Anne and give it to Ben, or vice versa, away from Ben and give it to Anne, then trading will end up at a different point, and I can control exactly what competitive equilibrium will be achieved through trade in this model. So let's do a number example where we would like to end up at this set of initial endowments where Anne has 2 units of X, 2.4 units of Y, Ben has 6 units of X, and 3.6 units of Y. So this is probably preferred by Ben, right? He's going to have more X and more Y than at the initial endowment, or where we would get by trading from the initial endowment. So what we want to do is develop then a set of transfers between Anne and Ben. And our transfers, of course, should equal 0. The government won't skim any off the top, such that we can achieve this competitive equilibrium. To do this, we'll again approach the problem from Anne's perspective. We need to simply think of Anne's budget constraint and her choice rule, and that will tell us what transfers are needed to achieve this point. So for Anne's budget constraint, I know that the value of her initial endowment must be equal to the value of this competitive equilibrium. Plus the transfer. Now I can simplify this equation to be the transfer as a function of Py. So my transfer plus 6 plus 2Py equals 2 plus 2.4 Py. So I'll subtract 2Py, subtract 6 from each side. My transfer is equal to -4 plus 0.4 Py. So what is Py? I can see that by looking at Anne's optimal choice rule. In other words, setting her marginal rate of substitution equal to the price ratio. So recall that her marginal rate of substitution is YA over XA. And again, we're assuming Px is equal to 1. So here we have this expression 1 over Py. And then what we need to do is simply plug in our competitive equilibrium to find the slope of her indifference curve at that point. So Py is equal to XA over YA is equal to 2 over 2.4, which I believe is 0.83 repeating. And now we can plug that back into this equation for the transfers. I get TA is equal to -4 plus 0.4 times 0.83, and that gives me -3.6 about for Anne. So if I take $3.60 away from Anne and I give it to Ben, then trading will result in this competitive equilibrium. So to sum up, the first fundamental theorem of welfare economics tells us that trade achieving competitive equilibrium is by definition Pareto optimal. All competitive equilibria are in the set of Pareto optimal outcomes, which we call the contract curve. The second theorem of welfare economics tells me that should the competitive equilibria I achieve be undesirable, the government can redistribute wealth to achieve some other competitive equilibria through trade. The government need not determine how much X and Y or Z or B or any number of goods each individual consumes, but can simply achieve a different competitive equilibria through a simple transfer of wealth prior to trade.